My name's Paul Wilkinson, and it's my pleasure to welcome Marina Villanueva to speak to thinkBIM this week. Marina is digital engineer and technical director at Jacobs in Melbourne, Australia. She wrote an article earlier this year on called "Wake Up, Digital Twins Are Unicorns," which attracted our attention, and we thought she'd make a good presenter for our digital twin specialist event. So welcome, Marina.
Thank you very much, Paul, and hello everyone. It's really good to be presenting here. Thank you for inviting me to present at this online event. So today I'll be challenging digital twins in line with the article that I wrote. I'm Spanish. I worked, as Paul said, I'm Digital Engineering Technical Director for the Asia Pacific region at Jacobs. That is a very Australian, New Zealand term. In other parts of the world, digital engineering is better known as digital delivery or simply BIM. My background is architecture. I'm a qualified architect in Spain and a specialist in computational design. I've got a postgraduate degree in computational design, and I'm currently studying business administration at the University of Melbourne. So I wanted to start with a little bit of context, you know, why or how we're challenging digital twins. Well, I got inspiration from a test that was created by Alison Bechdel in 1998. She created some comic strips, and in one of these of her comic strips, she presented two women talking to each other and discussing whether to go watch a movie. And one of the women responded that she would only be happy to go watch a movie if it satisfied three rules. Simple. They consist in like more than two women with names appear in the film, that they talk to each other, and they talk about something other than a man. So if you see if you look at the diagram, you'll see how movies have gone more equally, or you know, if they are displaying and representing women in a more egalitarian way, so to speak. So I was inspired by this test, and I wanted to apply a similar idea into this presentation for digital twins. So what is my test about digital twins? So I would call digital twin a digital solution that is aimed at improving the operations or use of an asset. That includes a virtual 3D representation of the asset, which captures real-time data of their context or their operation, and which eventually analyzes all this data in order to facilitate or improve decision-making for operations. Next, I'm going to show some use cases, and we'll discuss whether, how well these use cases perform against the test. The first example is from the automotive sector. I'm sure you are familiar with Tesla cars, and one of their most shiny features is that these cars, when they are on the highway, so they can turn on the Autopilot mode, and that allows, so that basically is like you don't have to touch the wheel, and it takes you from A to B. So the idea of this, or the technology behind this Autopilot, is that the car has to understand its own position at all times. It has to be able to drive from point A to point B. It has to manage traffic conditions in real time, and it has to be able to react to those conditions in a safely way. So in order to do that, the the software has got a 3D model of the car, and it knows where the sensors are positioned in reference to that 3D model, which is representing the real asset, the real car. Obviously, it also has a GPS, cameras and radar, and a software that compiles all that information, processes all this information, and makes and controls how the car behaves while driving in real time. So, so if we were to look at the different, the 4 items I listed for the V test, we would ask ourselves, okay, so does it improve operations? Yes, it improves operations, because during the operation of the car, while you're driving it, you don't need to touch the wheel; it drives for you. So the experience is more pleasant, and possibly the car reacts in a safer way when confronted to a complicated situation. Does it represent reality? Yes, it does. It does represent, so the 3D virtual model is representing the actual size and shape and position of the asset in the real world. So the software knows exactly where it is, and notes, and this is related to a virtual 3D object with information. Does it capture real-time data? Yes, it does. In order to manage the traffic conditions, it has these sensors and radars and cameras that are sending all this information to the software. So it does capture real-time data. And does it do some sort of data analysis for decision making? Indeed, the software uses machine learning and has a number of algorithms that are processing all this data in real time, so that the car can actually behave and modify its trajectory if need be. So it passes. Okay. So now let's have a look at another example. This comes from the aerospace industry. This is from Siemens, and this is how, so Siemens produces a suite of tools for industrial manufacturing, and it applies a similar approach in both aerospace and naval industries. So here we're looking at an ecosystem that not only seeks to maximize the efficiency, safety, and quality of the end product, but also of the overall process. So from design to manufacture to operations and maintenance, it establishes a feedback loop between each of the different stages. So they provide these specific tools to satisfy the needs of each stage, and then allow the transfer of data from one phase to the next. Eventually, a plane is produced with all its electronics and sensors and the software we are probably a bit more aware of, everything that is needed for the asset, for the plane to fly. And but it not only stops here, but also during the operation of the plane itself, the real-time data retrieved by the plane during the flight is not only displayed to the pilots, but also shared with the design and production team. So this is the feedback loop is not only with the real product and the design and production team, but also within the production process as well. So again, let's have a look at the test. Would this process, with all its software and the suite of tools that are part of this digital twin solution, would they improve operations? Well, to me that's very obvious. It's a yes. It's a massive yes, actually, because it's not just for the plane that it improves the operations, but also for the operation of the actual plant, the actual production plant. Does it represent the 3D object in reality? Yes, from the very beginning, from the design stage, they produce a 3D object that then is is transferred from one stage to the next, and then eventually the plane, during operations, it knows exactly where its sensors are placed. Does it capture real-time data? Yes, we've mentioned the sensors and how the whole production process, as well as the operation of the plane, is retrieving and capturing data. And does it allow the performance of some sort of analytics for decision making? That is the yes, big yes again. That is the main purpose of this solution, right? Retrieving data and analyzing it to continuously improve the efficiency and the quality and the safety of the both the production process, but also the plane. Okay, so it passes the V-test. Good. Next, and here I'm going to talk about 2 use cases from Australia. The first one is the New South Wales Spatial digital twin. So I'm going to play this video that lasts for about 3 minutes. I think it's quite interesting. It'll give you a bit more context, and also you'll see what it looks like.
As Australia's population continues to grow, our nation's urban needs are changing. Cities are expanding vertically and are growing increasingly rich in data. The power to combine, visualise and interact with this data has never been so important, which is why CSIRO's Data 61 and the New South Wales Government have created the Spatial Digital Twin. The digital twin is a powerful 3D plus time-live data sharing, collaboration and visualization tool that can be used by planners, infrastructure owners, developers, policymakers and residents to help better plan, design and manage our cities. Users can interact with a virtual replica of the Western Sydney region, adding and removing layers to visualise data and infrastructure such as under and above ground utilities, live transport data, roads, schools and hospitals, building materials, property boundaries and valuations, strata plans, 3D trees, or any other data fed into the system.
This visualisation service is quite comprehensive and sophisticated and allows us to bring together data from government, from industry and from the community, place it all in the right context and view it accurately and reliably. It's a very powerful communication tool. Without this spatial digital twin, we can't have smart precincts or smart cities or even a smart New South Wales, because this is the thing that actually coordinates and brings together all those different models and capabilities. Security is very important. We have a range of quite sensitive data, so the system is set up on a role-based user access arrangement that allows the data owner to specify quite specifically who can see their data and who's allowed to access it.
The digital twin also offers tools like a data splitter, allowing users to compare data at different times and see how infrastructure has changed.
We've been working with the New South Wales Government to create an open platform digital twin that can federate data from other digital twins and geospatial systems so that previously locked away data can be made much more accessible and usable. The digital twin aggregates high-value data like planning, property, infrastructure and environmental straight from the owners of those datasets. This ensures that governments and industry can use the same authoritative data to respond to many different issues in the built and natural environments. This data sharing can also be used to plan for, prevent and assist with recovery from natural disasters and climate change, and more broadly can be used to consult and communicate with the communities as these things happen. This is only the beginning of the journey. Our goal is to create a national digital twin to help understand our nation's infrastructure and well-being so that we can use data-driven decisions to plan for Australia's future.
See how CSIRO's Data 61 can help you turn data into decisions. Visit our website to find out more.
Okay, so now that you've seen what the New South Wales Spatial Digital Twin is, I mean, in my view, and I try to summarize the goal and the characteristics and the technology behind it. So in my view, yes, it is a public aggregated repository of aggregates multiple layers of data. It is an impressive first step to a publicly available data set that combines information about utilities, aerial imagery, historic images, some BIM models, information about transport in real time. And it is essentially a place to visualize all this information within its context. The main technology they've used to implement the digital twin is a WebGIS portal, and they also plug into some API services to retrieve real-time data from a number of services, namely transport services can be checked in real time, and you can see where the metro is at any given moment, right? I mean, how would it perform? So can we say that it improves operations or the use? Well, in my view, at the point it is now, that is at least questionable. In my opinion, at the moment as it is now, it is an aggregation of data repositories, but there is not a clear operational goal. We're going to use this solution to solve this problem or these problems. It is informative at this stage, which, I mean, you can argue being informative on its own is already a way to improve operations and maintenance. Maybe yes, but since it's my test, I've decided to give it a question mark. I'm not 100% it improves operations as it is now. Does it represent reality? Yes, very much. It does it in 3D, and it is an actual representation of what's going on in the city. So yes, does it capture real-time data? Yes, as we mentioned before, it is connecting to several API services, and so through these services, it is pulling real-time information, and it is displayed through the portal. Does it do any data analysis for decision making? No. At the moment, the data is, as one of the persons in the video mentioned, this is the start of their journey. Although I believe they will eventually be able to perform some analytics to improve decision making during operations, at the moment it is not doing any analytics. At the moment, I would say this does not pass the test, unfortunately, but it's a good, really good start. Okay, so the next one, and it's the last one, is the Victoria Fishermans Bend digital twin. Of course, Victoria couldn't stay behind New South Wales, and this is a little bit of an Australian rivalry there between Sydney and Melbourne. The context of this project is that the University of Melbourne and the Victorian government are partnering to develop this digital twin for Fisherman's Bend, which will provide 3D context and illustrate the human and built relationships within the local environment. This project is going to be Australia's largest urban renewal project. The precinct will accommodate 80,000 people and 80,000 jobs by 2050. At the moment, it is at a design stage, and I'm reading from their website. Its digital twin. This digital twin will be a global example of innovation and help Victoria achieve a world-leading renewable outcome. So again, I'm going to play this video. It doesn't have a voiceover, but it does have some music, so I'll just play it a little bit faster. So if I think I captured the goal and the main goal and characteristics of the Fishermans bend digital twin in this very list, and this very short list here to the left. So as a main goal, and it's in line with what it's publicized in the website. The goal of this digital twin, or better, I will call it digital solution, is to design, plan, and visualize this project, this renewal project. The characteristics of the solution is that it is again overlaying in a very similar way as the New South Wales digital twin is doing, is overlaying multiple data sets from GIS, aerial imagery, BIM models, and urban planning constraints. And it's also, this one's very focused as well, I would say, in visualization. So using the solution for AR, augmented reality. The main technology behind it, supporting this is WebGIS, as with the New South Wales Spatial Digital Twin. And there is also a persistent theme that we can find in both the previous example and this example, in which the concept of digital twin is sort of identified with 4D BIM, or what we know as BIM plus the layer of time, which in my view is a wrong understanding of what the concept of digital twin is. We say this improves operations or use. I think we are in a very similar situation as we were with the previous example. So I will not extend my explanation, since I think already provided some reasons as to why I consider this to be an unknown at the moment. Does it represent reality? Yes, similarly as in the case before, it will overlay multiple data sets that will be representing reality with a high level of accuracy. Will it capture real-time data? Well, that is a bit unsure. At the moment, from the video, it tells that, I mean, it says that it will capture real-time data or create, I think the exact phrase is, it will create real-time data using machine learning, which is a bit confusing for me. I think the terms are a bit messed, but anyway, so that's why I again consider this to be a question mark, because we don't know for sure what we will do. And in terms of data analysis for decision making, again, it is very early days. This project has just started. They've announced the Victoria Fisherman's Bend project, and the design is just going to start in the coming, probably this year or next year. So again, I think this is the start of a journey, and over time they will define what this solution is meant to do. So at the moment, I would say this is not a digital twin. All right, so we head towards the conclusions. I think from the 4 use cases that we've seen, well, there's this persistent idea that a digital twin is a 3D BIM plus time. I think it's not, and it does not match any of the definitions that come from the industry, like the Gemini principles or the IET report in that matter. So I think it would be good to start just calling things by their name. If it's 3D BIM plus time, then it's probably just a 4D BIM solution, but not a digital twin. I think as well, from the examples we've seen, and I'm going to concentrate on the built environment examples, so that the Australian examples more than the examples that come from other industries. The fact that there is a persistent lack of definition of what the operational goals are. So we are presented with these solutions, but there is an unclear end goal. What are we going to do with all this data put together? What are they for, other than being informative? Which is okay. If that's the case, then all right, that is good for the public. It will be publicly beneficial to have all this data together and in context. But in that case, if it's only for the purpose of overlaying data, I wouldn't call it a digital twin. It is the digital version of data that we have traditionally just stored separately on paper, but now it is available through a website. And then the other 2 topics that are also sort of lacking in the 2 examples is the lack of data analysis and also the topic of interoperability. So I think these 2 are very, very interrelated. If there is no good interoperability, then across the data sets that we put together, then it will be very hard to be able to analyze those data sets together or extract conclusions or help decision making for the operational phase. So speaking of interoperability, this is the last slide, and I want to share perhaps some thoughts that I think are relevant today, since I think it's the closing date for providing responses to the BIM interoperability report, right, Paul? So I wanted to share just a few thoughts about interoperability, generally speaking. I think it is widely recognized that the lack of a common standard is preventing the industry from advancing towards the use of information models during operations and maintenance, let alone digital twins, right? So if we were to produce information models that could evolve from design through to operations and maintenance, thanks to a consistent standard, the industry as a whole would be in a much better position. We would be working smarter, and we would be more efficient in the way we operate and manage our assets in the built environment. A comment about IFC and COBE. I think this particular report, and generally when we talk about interoperability on COBE, we are very focused on IFC and COBE, but it is taking so long. You know, I've got like mixed feelings about IFC and COBE, because technology, on the one hand, my main thought is technology is only widely embraced when it's easy to use. And IFC and COBE have been under development for many, many years. And yet, something's happening that they aren't widely used. And at the same time, because they aren't widely used, because they are still under development, people have started to look for workarounds to federate models, to federate models from multiple sources, and deliver some sorts of operations and maintenance data using alternative formats. So my question, should we really just focus on the pursuit of perfect IFC COBE standards? Should we look at other alternatives? Are there other alternatives that we could look at and perhaps consider? I don't have the answers to these questions, but I wish I had. But yeah, I think this is a big topic. It's one that is not easy to solve. Obviously, it will require involvement of software vendors as well as facility and asset managers. And well, I just leave here my contact details. You can reach me on Twitter, or just shoot me an email, or contact me through LinkedIn. I'm easy to reach and happy to be contacted. Thank you.
Thank you, Marina. That was excellent stuff. In the absence of an audience being able to pose questions, I'm just going to pose a couple, just because we've only got a short period of time left. I mentioned the word unicorns at the beginning. Do you want to just briefly explain what a unicorn means in the context of your digital twins article?
Yes, of course. It's a funny question. So when I used that word in the header, in the title of the article, it was in the sense that not in the sense that they are a fantasy, although I was playing a little bit with the word. But obviously, a unicorn is a fantastic animal. It doesn't exist in reality. But I was using more in the context of business, by which, well, a business is considered to be a unicorn when they reach a certain very, very high value. And since they are rare, very rare to find, they are called unicorns. So I was using that word in the context of the digital twins being very rare animals.
You mentioned the Construction Innovation Hub, the Centre for Digital Built Britain interoperability review. Closing date for that was 15th of May. Have you responded to that?
Yes, I have. I haven't responded on behalf of Jacobs. I have responded on my own. I've given and shared my thoughts, especially with IFC and COBE, in line with what I was mentioning in the in the presentation. The previous slide.
The point that came across very clearly also was the need to extend on the interoperability point, the use of data right across the whole life of an asset into operation and maintenance. Is that something that's being discussed in the Australian built environment industry at the moment?
Yes, so I think the digital twin concept is a hot topic worldwide at the moment, and we are seeing clients in Australia being interested about how to achieve a digital twin. Similarly, as we, like, say 5 to 10 years ago, we got clients asking for BIM, just give me BIM, without any specifics around the word BIM, right? Now we're being asked to deliver or to define digital twins because it's the new fancy word. Probably.
Yeah, the new industry buzzword.
Yeah.
Yes. I'd like to say thank you very much, Marina. This will be shared at the conference on 21st of May, and you've given your contact details, and I hope people do get in touch with you to follow up if they have any further questions. Thank you very much.
Yeah, of course. Thank you very much to you, Paul, and thank you to all the thinkBIM people. Thank you for inviting me. It was a pleasure.